Earth was formed from the remnants of a massive cloud of dust and gas that collapsed to create the sun. This leftover rubble spun around the sun, eventually forming our planet. Since its creation, 4.5 billion years ago, Earth has never stopped rotating. But recent discoveries suggest that Earth's rotation is actually slowing down and could one day stop. What does this mean for life on Earth, and how long do we have before this happens? Imagine traveling back in time to the Neoproterozoic era, which lasted around 620 million years ago. The Earth would look quite different back then. You'd see strange plants and worms that might make you want to jump back into your time machine, but another big difference you'd notice is that the days were shorter. Instead of the 24-hour days we have now, a day back then was only 22 hours long. This is because the Earth was spinning faster. Over billions of years, Earth's rotation has been slowing down. Even now, it's still slowing down a tiny bit, adding about 1.8 milliseconds to the length of the day each century. The length of the day doesn't just change our centuries, it also fluctuates from year to year. This is due to various forces acting on Earth and its rotation. Scientists are still trying to understand all the factors that affect these changes. However, with the development of very sensitive instruments, they can now measure changes in the Earth's rotation down to the microsecond. They have discovered that every day is slightly different from the one before. Since its formation, Earth has been spinning like a top. This spinning started because of the gradual gravitational pull of dust and pebbles in space coming together to form the planet, but once the spinning starts, it doesn't stay the same. Earth's rotation is influenced by both internal processes, like movements in its core, and external factors, like wind patterns on its surface. Thanks to a technique called very long baseline interferometry, scientists can detect even the smallest changes in Earth's rotation. This method uses a network of space telescopes that observe signals from distant objects in the universe. As Earth rotates, these signals come into view and then move out of view. By timing how long it takes for these signals to disappear and reappear, scientists can measure the precise rotation of Earth. There's not much we can do to stop the Earth's rotation. Think of a playground roundabout. When you stop pushing it, it eventually slows down and stops because of friction from the air and the ground. But Earth spins in the vast emptiness of space, where there's no air to slow it down. The main force affecting Earth's rotation is the moon. The moon has been gently pulling on Earth for billions of years, slowly decreasing its rotation. Back in the Neoproterozoic era, days were shorter because of the moon's pull, and in the future, days will be longer. This happens because of an energy transfer between Earth and the moon. The moon's gravity creates a small bulge on Earth, which isn't exactly under the moon. This difference creates a torque that slows down Earth's spin. As the moon moves away from Earth by about 1.5 inches each year, some of Earth's rotational energy transfers to the moon. This process has been ongoing since the moon started orbiting the Earth. Scientists estimate that 1.4 billion years ago, a day was only about 18.7 hours long, and the moon was 27,000 miles closer to the Earth. The bulges in Earth's surface move like a wave, pushing against Earth's rotation and slowing it down. Because of this, the length of a day increases by 1 second every 50,000 years. The only way to completely stop Earth's rotation would be if another planet collided with it. Even then, it would probably just change Earth's rotation rather than stop it entirely. Many factors affect how quickly Earth rotates over shorter time spans. The movement of the Earth's molten core is one of the most important of these factors. It is unclear how much the turbulence within the liquid interior of our planet affects the rotation of the entire planet. Observing the Earth's core is challenging, and researchers are still unable to determine how much of it affects the planet's orbit. The wind and wave motions on Earth's surface also affect how quickly the planet rotates. Both the wind and the tides that swirl the waters have an impact on rotational speeds. Because of friction, air currents drag on the Earth's surface and push against mountains, somewhat altering how quickly Earth rotates. The Earth rotates a little bit slower, for instance, during El Niño years because of how the winds change. According to researchers from NASA's Jet Propulsion Laboratory, the Earth's rotational speed can also be influenced by seismic activity. The Earth's rotation accelerated by around 3 microseconds after the 2004 earthquake that wreaked havoc on Indonesia and other nations bordering the Indian Ocean. As continental plates moved, there was a tiny shift in the distribution of Earth's mass, which led to the effect. The planet will spin more swiftly when mass moves closer to its center, similar to how a figure skater rotates quicker when they pull their arms in and vice versa. As a direct result of Newton's rule of conservation of energy, the Earth's rotation rate is constantly changing. Relatively, more mass is moving in the form of meltwater from close to the poles to closer to the equator as glaciers melt and sea levels rise. That slows down the rotation of the Earth and progressively lengthens our days. The speed of Earth's rotation also fluctuates seasonally, picking up speed during the northern hemisphere's summer and slowing down during the winter. This is because of the Earth's orbit moving it closer to the sun during the winter and slightly farther away during the summer. Because of momentum conservation, as the Earth gets closer to the sun, its rotation slows down to compensate for the increased speed of the planet's motion. Thus, what would occur if it would eventually cease to spin? Well, for one, you wouldn't be propelled into space at a moment's notice. If the Earth's rotation stopped, you would still remain securely on the ground thanks to gravity, but there would be a lot of adjustments. A day would last half a year, as would the night if Earth were to stop spinning, yet keep orbiting around the sun. It would become much warmer during the day and much colder during the night. This would impact the Earth's climate. Strong winds would result from a significant temperature differential between day and night, which would pull warm air toward the Earth's cooler night side. Additionally, the wind would go from the warm areas near the equator to the Arctic regions. This does not occur on a rotating Earth because the wind is redirected to the side. The winds from the east and the west, as well as the winds from the poles, would collide, and they might produce enormous wind swirls the size of entire continents. Part of the Earth's core is made up of molten iron. This molten iron becomes a magnet due to the Earth's rotation, which also creates a magnetic field around the planet. This shields us from dangerous radiation that originates from solar particles and cosmic rays outside the solar system. The magnetic field prevents the radiation from reaching us, but when it does, it interacts with the atmosphere and causes the aurora, often known as the northern or southern lights. However, this radiation might harm humanity if it reaches Earth's surface without the magnetic field. Some birds rely on the magnetic field to navigate, thus they would become disoriented if the Earth stopped spinning. If the Earth didn't spin, you would always be facing the same direction into space. Thus, you could always see the same constellation of the stars in the night sky. Seeing the constellations shift year over the year, and the stars rise and set during the night is quite different from this. However, try not to obsess over how quickly your days go by. The discrepancy is small and in line with previous fluctuations in Earth's rotational speed. Therefore, even though the days may never be exactly the same length and you may never see Earth as it is again, changes in the planet's rotation should be quite low on your list of concerns.